What would happen to us and our planet if it became as big as the Sun? The diameter of the Earth is 8,000 miles. Crossing it would be like driving back and forth across the USA 3 times. That doesn't sound like much, right? Now imagine repeating this journey 305 more times. Just think of the gas expenses. That would give us the diameter of the Sun, which is about 865,000 miles. Compared to Earth, the Sun is unimaginably huge. So what would happen if the Earth caught up in size with the Sun? There are 4 possible scenarios, depending on what we mean when we say the size of the Sun. Scenario 1, the Earth becomes as large as the Sun, but its mass remains the same. In this case, we would have a colossal planet with the mass of a tiny Earth. First, say goodbye to gravity. The more massive a planet, the stronger its gravity, and vice versa. A planet this lightweight simply wouldn't be able to attract anything to itself. Gravity holds all heavy substances together, from pebbles to entire continents. Without gravity, everything would turn into dust particles. The Earth would become a dust cloud, and other planets' gravities would stretch it out, leaving no chance of putting our planet back together again. Even if the Earth somehow remained a planet, life couldn't have developed. The distance between the Earth's center and its surface would be huge, but with its minimal mass, there would be no gravity to hold the atmosphere. Without an atmosphere, no living organisms could evolve. But since the Earth is now a cloud, things have already gone downhill. This dust cloud, now 10 times heavier than Jupiter, would eventually collapse and form a star. Say hello to the new Sun. Scenario 2, the Earth becomes as large as the Sun and also gains its mass. Now we have 2 suns, transforming our solar system into a binary star system. What does this mean? It's time to destroy our solar system. With 2 centers of mass, the planet's orbits would become unstable. Any planets getting too close to our Earth would either collapse from tidal forces or be destroyed by the Earth's impact. Even gas giants like Jupiter wouldn't survive. Interestingly, Pluto, being so far away, might be the last planet standing. As the system adjusts, Pluto's orbit would bring it closer to the 2 stars, and that's the end of the solar system as we know it. But what about life on Earth? With the Earth's increased size, days and nights would be longer due to a slower rotation. The temperature at the poles would likely drop significantly, receiving even less sunlight than they do now. While there would be more space and overpopulation wouldn't be a concern, traveling across this massive Earth would take years. Loneliness might become a serious issue, and rockets could become the primary mode of transportation. Vast uncharted regions would exist, filled with civilizations and tribes that might never meet each other. Physically, our bones wouldn't be able to support us due to the increased gravity, and our hearts would have to work twice as hard. Birds wouldn't be able to fly, and trees would grow close to the ground like grass. The environment would suffer drastically, with massive land areas being overwhelmed by human waste and pollution. On top of that, the planet might be much darker, and we might need an artificial sun to compensate for the reduced natural sunlight. Overall, life on this enlarged Earth would be quite different and challenging. Scenario 3. The Earth becomes as large as the Sun but retains its density. In this case, the Earth would no longer be a planet, it would be a star, even more massive than the Sun. With 3.9 times the solar mass, our new Earth would burn through its fuel faster. Eventually, it would either go supernova or blow off its outer layers, forming a planetary nebula. If it goes supernova, the Sun would be obliterated, and our Earth would be left as a tiny dense neutron star, spinning rapidly. If it turns into a nebula, the Sun could collect the remaining dust and increase its own mass, continuing its life cycle until it too becomes a red giant. In either case, our Earth's fate would involve immense changes, leading to the end of the solar system as we know it. If Earth becomes a neutron star, it would be a hyperdense object, dangerous to be near. If it becomes a nebula, the Sun might even reignite into a new nova. However, in any scenario, life as we know it would be long gone. Scenario 4. While it's impossible for a rocky planet like Earth to become as large as the Sun, it's worth pondering why Earth is so small compared to other celestial bodies. As planets gain mass, their structure becomes more compressed. There's a limit to how big rocky planets can grow before they turn into stars. The more mass you add, the more gravity compresses the matter within, affecting the planet's density and structure. The more massive the gravitational compression, the stronger it becomes. Planets stop growing when their mass reaches roughly 1.7 times that of Jupiter, or 540 times the mass of Earth. After that, Adding more mass to a planet makes it smaller because the compression increases. In other words, the idea of a planet growing infinitely large is impossible. Now let's face it, as stars go, our sun is actually pretty boring. There's nothing particularly unusual about it, as there are millions of similar yellow dwarf stars in the universe. Still, we love it. After all, it's the only star we have, and it gives us life. However, it wasn't always like this. Once upon a time, the sun might have had a twin, possibly an evil one. What happened to this mysterious sibling? Let's explore further. Giant molecular clouds, also known as dark nebulae, are vast collections of gas, dust, and stars, often with no clear boundaries and bizarre shapes. You can even see them with the naked eye as dark spots in the Milky Way. About 4.5 billion years ago, the sun was born in one of these molecular clouds. Waves of energy passing through the cloud collected and compressed material, forming dense clumps, and from one of these clumps, a protostar emerged. This young protostar was a ball of lukewarm hydrogen and helium. Over millions of years, its temperature and pressure increased, and eventually a star, the sun, was born. However, not all the material in this molecular cloud became part of the sun. The leftover material began to orbit the new star, and over time, it coalesced into planets, including Earth. This is how our solar system was formed. But there's a possibility that this isn't the whole story. Along with the sun, another star might have been born, a lost twin of the sun, formed under the same conditions from the same materials. Why do we think this twin existed? Recent statistical models suggest that many stars are not born alone, but instead form in clusters or with at least one sibling. Further research has shown that most stars born in molecular clouds have companions. Sometimes these companions remain together, forming binary or multi-star systems, while other times their paths diverge. It's possible that the sun had a sibling, or even a whole cluster of star brothers and sisters, including one twin with similar characteristics. But if this is true, where is the sun's lost twin? One hypothesis suggests this twin might not be as benevolent as we would like to think. In the 1980s, scientists noticed a strange pattern in Earth's history. Approximately every 27 million years, large-scale extinctions occurred. It seemed as though some cyclical event triggered these catastrophic changes to Earth's biosphere. Astronomer Richard Muller proposed that these extinctions could be caused by a distant celestial body, a dwarf star, invisible due to its dimness, orbiting the sun from about 1.5 light-years away. This star, taking 27 million years to complete its orbit, could disrupt the comets in the Oort cloud or the Kuiper belt when it gets close to the sun, sending comets hurtling toward Earth. These collisions could cause mass extinctions, just like the one that wiped out the dinosaurs. This hypothetical star was named Nemesis, after the Greek goddess of retribution. But is Nemesis real? Despite efforts to find it, no clear signs of Nemesis have been detected. Some recent studies even question the theory of regular mass extinctions, suggesting that such events may have occurred more randomly than cyclically. Scientists also argue that a star in such a long and unstable orbit would likely not have survived for billions of years. Nevertheless, the idea of Nemesis has become popular in online discussions and is often blamed for various cosmic events like asteroid impacts or tsunamis. Even if Nemesis doesn't exist, the possibility that the sun once had a twin remains. Most stars are born with companions, so it's still highly probable that the sun had a sibling. Additionally, there might be evidence of this lost twin in the Oort cloud, a vast region at the edge of our solar system filled with comets and remnants from its formation. This cloud appears to be heavier than current models predict, hinting at something we haven't yet identified. When scientists included a potential second star in their calculations, everything fit perfectly. This lost twin could account for the missing mass in the Oort cloud. So, it seems highly likely that the sun once had a twin. But what happened to it, and where is it now? Unfortunately, this twin is probably very far away by now, having drifted away long ago after its birth alongside the sun.